Hello, hello. This week's Fiddler is a little bit weird. I am a little confused about the question in the sense that, what you'll see in a second, that I think my answer is correct to the question asked, but because of the way it was asked, I think perhaps another question was intended that I don't understand, or maybe I'm misreading the question. But anyway, the question talks about a slice of pizza, which we have in a delicious cheesy yellow here, and we want to wrap it in tin foil. And the question is, what is the minimum area I can use to wrap this pizza using only a rectangle for our original shape of the tin foil? So I can fold it as much as I want, but I can't tear it, and the original shape has to be a rectangle. So those, as far as I know, are the only restrictions on the foil. And given that, it seems to me that you can wrap it quite nicely with basically no extra area required. And this is going to hold for any shape. And so when we get to the extra credit of two slices of pizza at the same time, you basically are going to get the same method and the same answer. So here I have this rectangle of tinfoil, which is kind of long. And what I'm going to do is I'm going to wrap it over the pizza. And then I'm just going to fold it along this dotted line here and have it wrap back around the back of the pizza so that it extends through to the other side. Now, once it's wrapped over, I'm going to fold it along this dotted line here at a 45-degree angle so that once it's folded, the tin foil will now wrap straight up, or be pointing straight up rather, toward the top of the pizza. And then I'll fold it again along a 45-degree line again so that it will wrap back towards the pizza, and it will just kind of barely touch the foil below it. All right. And I'm going to repeat this process over and over again, right? Back over and up until I get to the top of the pizza. And then I wrap around the back. And now every single square inch of this pizza is covered in tin foil. So a couple questions here, namely, what is the area that I have here, and can I do better? Well, before I answer the question of what the area is, let's just think about, can I do better? So what can I do using a very similar strategy that would do a little better? Well, we'll notice that what is the extra here? The extra is just these kind of extra triangles front and back on the right side of the pizza. I've got a lot more on the left side over here, right? I've got these big overlapping triangles, some open rectangles, right? I've got a bunch of shapes here. They're all extra area, right? And some, like in these little tiny triangles here, I actually have four pieces of tin foil, essentially, like two from this triangle and two from this triangle that are overlapping. So it's kind of four sheets of tin foil in this little spot. So there's kind of a lot of extra tin foil on here. So what can I do to minimize all this extra? Well, let's unwrap this uh, and go back. And let's just make this tin foil a little bit thinner. So I'm just gonna decrease the width of my rectangle here. I'm gonna do the same process. Now it's gonna take a lot more wraps this time, right? So if I go slowly, it's gonna take forever. But I'm just gonna quickly go through this wrapping process where I go up and around. I mummify this pizza in this thin tin foil. And so what I can do here is just zoom back a little bit and make the strips a little thicker and watch what happens, especially to the left side of the area here, right? It just gets quite a bit bigger as I head back to wider and wider strips, right? And so the inverse of that, of course, is that the if I make the width smaller and smaller, that area on the left side and the right side of the triangles are going to get smaller and smaller as well. And hopefully if I just put these side by side, it'll be a bit more intuitive that the area on the foil from the right triangle over here is, notably quite a bit more than the area when I have a larger number of strips with a smaller width. And actually here you can see a little plot of the area of the foil as a function of basically how thin. I mean, the number on the bottom here is basically how many layers I need to do to get to the top. So the more layers I need, the thinner that strip is going to be. And by layers, I just mean number of strips that go from the bottom to the top. And as you kind of get more and bigger, or the width of the rectangle gets smaller and smaller, our area is going to decrease asymptotically toward this red dotted line here. Now, what's this red dotted line? Turns out that red dotted line is just the front and back area of that triangle. If you want something a little bit more formal to show that it is going to end up being the exact area of the triangle, what I can do here is consider, this 4-wrap slice of pizza, and think about how I can bound, meaning put an upper limit on how much foil this is going to require. So what I'm going to do here is, on the left side, I'm going to make this parallelogram that starts at the very left tip of this corner of the last triangle here, and it goes down to the pizza itself. And I'm going to have it just barely touch the tips of all these triangles. If I do that, then this side of the shape is going to be parallel to the slice of pizza edge, right? And I can then extend this to as high as I need to, such that these, the top and bottom sides here, are going to be parallel as well. So I have this parallelogram, right? And the length of this side is going to be 10, because it's going to be exactly the same as this pizza slice. And then this side is going to be equal to this side. And if the width of this rectangle is W, then the diagonal, this is going to end up being, because it's a 45-degree angle, this is a W right triangle. And so that hypotenuse is going to be W root 2. So I have this parallelogram with sides 10 and W root 2. And then I can think about, well, what's the area of the foil inside here? And I could calculate it exactly, but I don't need to make the point I want to make, and just say, well, what is the highest number of layers of foil that I might have inside this parallelogram? Because importantly, right, this parallelogram contains all the foil on the left side. So at most in these little triangles, I have 4 layers of foil, right? 2 from this triangle and 2 from this triangle. So I could have 4 here. And the area of the parallelogram itself is definitely going to be less than the sides multiplied together, right? I could figure out exactly what these angles are and figure out the exact area of this parallelogram. But again, I don't really need to. So I'm just going to say that the area of foil inside here is less than 4, because that's the maximum number of layers I can have, times the sides of this parallelogram, which again the area is going to be less than those sides multiplied together. So my foil area is going to be less than, for sure, 40 times W times root 2. Now you'll notice that this just perfectly scales with W. And so as I make W close to 0, the extra area of foil is also going to go down to 0. So because of that, the extra foil I'm going to need on the left side is going to be some arbitrarily small amount larger than 0. And I can make that as small as I want. And so effectively, the area I need is just, in the limit, the area of the triangle itself. And on the right side, you could do a similar exercise, but actually you could just say exactly that these 4 triangles here, but it turns out that it doesn't matter how many triangles you have, doesn't matter how wide it is, as long as it exactly ends up meeting the top of the triangle. The area on the right side is going to end up being 5W. So again, but we can make the same argument on 5W as we do with 40W root 2, that as W approaches 0, that's going to become arbitrarily small. So we have an arbitrarily small amount of extra foil to worry about, that in addition to what's exactly over the pizza. So anyway, hopefully I've convinced you that the area of foil needed is exactly the surface area of the shape, no matter what that shape is. And so, I mean, if you have a shape that does weird loop-to-loops and stuff, you might have to think a little more carefully about how to do the folding method. But basically, this type of wrapping procedure should work on, or something similar to this wrapping procedure should work on any shape, not just triangles. And so the extra credit is going to have the exact same answer, just doubled, because there are 2 slices of pizza. So anyway, that is all I have this week. Short video today. So hopefully that answers any Fiddler questions you have, and I hope you tried testing it out first. Have a good week. See you next time.